Second.
Okay, hi everyone. Good evening and welcome to this workshop on APIs and web development. So this workshop is going to be held by Sourav Raveendran from third year CSC. And before we get started on the workshop, we have our professor who is in charge of the lab. This is Venkatarangan sir from the EEE department. So he'll just share a few words with us before we get started. Yeah, over to you, sir.
Yeah. Okay. Thanks. Thanks very much, Tejas. Thanks to the organizers for inviting me. So morning, I just had got into the call and I was hearing to the. So who was it in the morning? I forgot the name. Tejas. Who was it? The morning speaker.
There was Akshay, sir.
Yeah, Akshay. Yeah. So it was fantastic talk, and I really felt that some of these topics are also very well covered by a lot of the students. And in fact, just quickly to brief you about the PES Innovation Lab, I was little hesitant to get into the talk before we start on this technical talk. But since it's good for a lot of you people to understand what this lab is about and how is it being organized. So Innovation Lab has been there for more than 5-6 years now. So I have been as part of this for last 4 years or so. So many years back, Dr. Srinivas, who is not with us, is dean in Dayanand Sagar University, and also Professor Rajshekhar, who addressed some of the students this morning who attended. Based on the Microsoft funds, it got started in a smaller way, and it has grown to such an extent that this lab is a kind of unique. Why I say it is unique is most of the lab, we also have one robotics center that we have. Most of those labs have a theme already, and we have projects specific around those those focus areas. This is a lab where we have been coming into every summer together. The ideas being proposed by a lot of students and the faculty members, and so there is a combination of the ideas that's been put across for the summer internship program, which has been going excellent for the last few years. So that way, I always say this lab has been a great model on how we should work. And the best part of this lab is look at Tejas, Abdul, Sourav. So many of them are putting in so much efforts, and I always say this lab has been by the student, of the students, and for the students, and it's completely run that way. So we are there as faculty just to give little guidance, but the primary activities has been done by a lot of passionate students, and therefore we have also got quite some network these days, and they have a lot of fun more than the technical part is always there. In addition, also have a lot of fun getting together, and unfortunately we are losing the fun part because of the COVID issue. Otherwise, we would have loved to see you all together, and would have loved to interact with you. And I'm sure I know Tejas, all of those guys have been calling us so many times. Can we do something for the internship? And it was unfortunate that we could not get together this time because of the COVID issue and take up some serious projects as part of the internship. But the idea of coming up with this presentation is really great because when it's coming from the students, they have already gone through the process, and they know quite some insights into this. So I would really love you to engage with these labs. please take the best advantage of what Tejas, Saurav, and other organizers are trying to organize. Again, they have been doing this very, very selflessly. Thanks to them, because they just want to get the best benefit to all the students of the PES University, and that's how this has been arranged. So please tune for some of the activities that we are going to have. So we would have had internship. So we don't have that internship. Instead of that, we have a series of talk by a lot of passionate students and those who are quite knowledgeable and have worked on it. Following this, I think we'll have ideathon and a few more activities that are going to come up. And I'm sure many of you are first years and second years, you're going to continue. Please look forward for the activities of this lab. And we want a combination of students, first year, second year, and third year, so that there's a good continuity going forward. And it makes a great place to work then, because the joy of learning will happen with students coming together. And that's what we look for in this lab. And obviously we will have students of the best caliber, the best attitude you can see, and they all have great communication. It would be I would love to see some of you going forward as part of the lab. So I think I will leave it to Tejas and others to take it forward on the specific topic that we are going to speak today. So please tune to the activities of the lab. Please look at the activities that we have done in the past, the projects that we have executed in the past, and we are also open to some of the new ideas that comes in. And this primarily the internship and a lot of these projects has been based on many student ideas. So I would really welcome for some of the activities to the Microsoft Lab, and please register and take the opportunities wherever possible. And we are here to support you to the best possible extent. Thanks once again for this opportunity to address you. Yeah, thank you.
Yeah, thank you, sir. Yeah, so Saurav, we can take it away.
Okay, so we'll go over to Saurav.
Okay, so hello everyone. Welcome to this workshop on APIs and web dev. So this is going to be a fairly introductory course. So for those of you who had no experience in these topics beforehand, it's perfectly meant for you guys. So a little knowledge of JavaScript or HTML might help, but that's entirely okay if you're unfamiliar with it. So as mentioned before in the emails that you would have received, I'll be using Node.js in this workshop. And I don't expect you to know Node.js, of course, but the key takeaway would not be the tech itself, but rather, how an API is expected to work, how you'd interface with your client, with your API server, so on. So after this workshop, hopefully you'd be able to pick up any other backend framework because you know what exactly you need to look for. I need so-and-so things, and maybe this framework supports it. I just need to find out how it's supported. So for those of you who are already familiar with maybe backend dev, how to use APIs and all of that stuff, what you could do, you could still stick on to this workshop. Hopefully, you might learn something, or maybe you could look for something that maybe I might do something wrong. You could spot it out on chat or whatever. Hopefully it's a constructive learning experience for all of us involved here. Okay. So now let's get into what exactly an API is. So an API stands for an application programming interface. So obviously it sounds like a mouthful, but it isn't a hard concept as such. And most of you have obviously used APIs before, and some of you even might have Googled things like, a weather API or a news API and so and so. But let's talk about what exactly an API is. So an API is used whenever you have two different applications and you want them to interface or communicate with each other somehow. So now there are a lot of reasons why you might want to do that, and a very a proper the use case that comes to mind first is maybe you've written some code and you want to create a GUI for it, and you want your GUI to interface with the other code that you've just written. So I'll bring about a basic example to talk about this, and say let's say you have a calculator application. So forget the GUI for now, and it does not matter what language you're writing a calculator application in. So for the sake of simplicity, let's just assume that the calculator has 4 different methods. You have an add, subtract, a multiplication, and a division. Now all of these are binary operations. So the input it takes and the output it provides is very well defined. So all of them take in 2 numeric inputs as arguments, and the result would be 1 numeric output. So this is a very important point to note, that the input and output is very well defined. So now let's say that we have written our functions, our add, subtract, multiply, and division. They're fairly simple to write in any programming language. So we've written that. And for the sake of this example, let's assume that it's actually more complicated to write an add or a subtraction method, because let's assume that the language does not support a plus operation, so you need to do a lot of other things to actually add 2 numbers. But just for the sake of this example, and in the end, all of that code that you've written to add, subtract is over here, and all of that would be exposed via a single function call that is over here. So now what's happening is you want to create a GUI for this, and again for the sake of this example, let's just assume that the GUI is also written in the same language. And what you want to do is, when the user clicks the plus button, the addition function is going to be called, and subtract, so on, for similar things. So essentially what you're doing is, this is a program on its own, the GUI program, and this also is a program on its own. And here you have these 4 functions that are exposed to the GUI to make use of this program here. So this constitutes your API in essence. And each of these individual functions in your API constitute API endpoints. So your add is an endpoint, your subtract is an endpoint. So to someone who is creating this GUI, they need not know what's happening here. All they need to know is they need to look at the documentation of these methods and just call that, because the input and output is very well defined. Okay, so this in essence we have covered what is an API is, because it's just a way to interface between 2 applications. Okay, so now we've covered what an API is, and obviously now you know that APIs are all over the place, and if you want to write a program that you want to be used by someone else, you write wrapper methods, you document them well enough, and so the user knows what exactly to call and all of these stuff. So even certain operating systems also do provide APIs. In fact, all operating systems provide APIs, so that developers who are developing applications for those operating system, they might be provided with certain features. Like let's say you want to create a window on a particular operating system. The operating system of choice would obviously provide an API for you to call a function call that will pop up a window with a certain title bar, a certain content, so and so. So a lot of people who have probably done graphics programming in Python using tkinter or all this, you would obviously have called some window.open method or something. So that's basically an operating system call that's being invoked under the hood. So now in a nutshell, we've covered what an API is. So now again, this workshop is about APIs and their usage in web applications. So let's again go back to our previous calculator application, and let's just say that your addition, subtraction, multiplication, division happen to be on some computer that's very far away. Again, for the sake of this example, let's just assume that I'm on a computer that's somewhere else, and my computer is incapable of adding, multiplying, or subtracting, or dividing 2 numbers. So if I wanted to do some mathematical operation on my computer, I need to use the program that I've defined on the computer that's far away. So if I need to do that, obviously I can't just invoke a function call or so that API that I created before is not really relevant to my usage right now. Now obviously it'll be known that since the computer is so far away, I need some sort of a network to access that program on the other computer. So now I have a computer here, there's another computer over there, and there'll be a network access between the two computers, and so and so. So now if I want to pass two numbers from my computer to the other computer, I have to pass to this network. So now some of you who know about computer networks probably know about network protocols. So there's a lot of network protocols that are actually involved in sending a message from one computer to another. Some of these protocols are very low level. They are concerned with actually passing the message through a wire or through a medium. And some of these protocols are very high level. So they're all very nicely, encapsulated and abstracted. So we only need to worry about the higher level of abstraction. That's, the protocols that work at an application level. HTTP is the most prevalent protocol at the application level. So you can imagine somehow that I'm going to be sending a HTTP message from my computer that contains these two numbers, and here it'll receive my HTTP message over this network that contains the two numbers and the operation that it wants to perform. It'll compute that and send back here. So in essence, what I'm doing right now is, my two numbers, I am requesting for this computer to compute an operation, and this computer is serving back a response to me. So, a keyword over there, I use the word serving, and that's not an accident, I use it on purpose. Now the computer's function is to serve a response. So we could technically call this a server, because what it's doing is serving me a response. So that's actually why servers are called servers. So this computer, I'd call it a server. So now there's actually, there could be a confusion. Now, is the program that is running here called a server, or this computer itself called a server? Now that's really up to you. The program and the computer together are my server. And you could call the program itself as a server program that's running on server hardware. So sometimes it could be a dedicated server whose main purpose is to serve requests. So that doesn't really matter anyway. And so now this computer that was sending my request to the server, I called a client. So now all that my server is doing is it listens to a request from a client and serves a response. So I could have tens of thousands of clients all connecting to one server, sending HTTP requests, and then my server sending back HTTP responses. So this essentially is a client-server architecture, and it's very popular. So if you're using a website on the internet, there is a server that is sitting somewhere, and you're the client, and it's sending back a web page to you, and it's being rendered on your browser. So now that we've covered the client-server architecture, there might be a point to note over here. The previous program that I wrote, that I mentioned over here, just has my add, subtract, multiply, and division function. Okay, so since these functions, now if I were to put it on my server, they have no ability to read my HTTP message or whatever. There has to be another program, an intermediary program over there that actually takes my HTTP message, it parses the HTTP message, determines what it needs to do, and then calls this API that is provided here. So now that intermediary program over there that is passing my HTTP request and then finding out what it needs to do and then sends back a HTTP response, that would be my API endpoint for this client-server architecture. So that constitutes my web API, and I could have endpoints over there. I could have different URLs for an add, subtraction, multiplication, or a division, and the address would be specified, and I'd call it. So the web API over there is our intermediary server program that connects with this program that I created over here, and I call it an API. What I'd also be covering in the rest of this workshop is how to create that intermediary program, how to write an API, how to write API endpoints, how to get a website to maybe send a request, and how to send a response back. I'll be covering that, and I'll be using Node.js for that, but the concepts I cover here are not limited to Node.js. You could use any language like Flask or anything, but we'll get to that later. So now I'll actually, let's do this first. Okay, so now I've spoken about HTTP, and HTTP actually, like I said, it's basically a protocol that signifies, over a network, when two applications communicating with each other, how exactly messages should be sent. There's actually a more concrete HTTP message format, but I'm not going to cover it here because it doesn't really matter. You're never going to look at a HTTP packet directly. You have libraries that pass it for you. But, if you're curious, you could always look up what the message format for a HTTP packet is. Anyway, so HTTP, for our use case, there are 4 main methods. So when you have a network, when you're sending a request, there are 4 things that you could mainly do. So the 4 things that you could mainly do are you could request to view a resource, or you could request to create a resource on the internet. That would be, when you're signing up for to a website or something like that, and you want to create a user. And another thing that you could do is you could update a resource that's already available on the server, or you could delete the data. So, create, read, update, and delete, they're the most, important functions if you have a database application. I think those are the most 4 important things. Get includes querying, any of that stuff. So HTTP internally supports 4 different methods: a get, a post, a put, or a delete. And a get is used to, query information if you just want a response back that corresponds to some address. Post is if you want your client to send data. So again, if I were to talk back to my calculator application, let's say I want to, view the history of all calculations made on the server so far. So my server, I could define a get endpoint, and somebody could call that, and I could view everything. So the thing is, to view history, I don't need to, pass any data to the server. I'm just querying for something like give me all the history, and it's giving it back to me. A post request would be if I want to actually perform an operation, a plus or a subtract or a division or a multiplication. I would send in 2 numbers, so that would be a post request, and that makes sense. For a calculator application, a put does not make sense, but you can imagine you want to update your password, you want to update your profile picture or something. You're actually updating a resource that's already on the server, so that's a put request, and a delete request makes sense. So if this does not make sense immediately, don't worry about it. I'll actually show you a real example where it's happening, and it'll make better sense then. So response codes, when an operation, when your server performs an operation, it needs to inform the client if it is successful or if there is an error or not. So for HTTP, we have error codes like this. So 200 or an error codes are usually 3-digit long, and it's ranging from 100 to like 500. And a 200 or an error code that starts with a 2 implies a success, meaning your request was successful. A 300 error means your request was redirected, meaning let's say you sent a request to a server and apparently that server is down, and there's some other server that's taken over. So this server would redirect your request to another server. So that's a redirection response. And 400 is a client-side error. I think the error code 404 is the most popular one. A lot of you would have seen this happen, and I'll get to that. I'll show you an example of a 400 error happening in real life. A client-side error is usually when you're sending a request that you made some mistake with the message that you sent to the request to the server. So that's a client-side error. A 500 error is server-side error, meaning the client requested properly, the request object was proper, but the server went through a problem while processing the request or something. So that's a server-side error. Okay, so I think I'll show an example right now of HTTP happening. So let's say I were to visit google.com. Okay, so what's happening here is I requested google.com. I just typed in google.com to my browser, and I got a web page over here. How exactly did that happen? So I won't go through all the underlying protocols like DNS and all of that. I'll immediately get to the HTTP scenes. So what's happening is here, when you type in google.com, the browser tries to find the IP address of google.com, and what it does is it automatically sends a GET request to Google server. And Google server, they have an API over there. They have a server sitting over there that is listening to requests, and it sees that someone's requested for google.com. And the API is programmed in such a way that when someone requests for google.com, this data, this web page itself, would be sent back to them. So I'll show you that happening right now. So what I did right now is open the developer console. On Chrome, you can use F12 to open it, or you can right click and inspect element and then go to the networks tab here. Okay, so You know what, I'll reload this. And when I reload this, you can see, so the networks tab just shows all my outgoing messages requests over the network from this particular page and all the incoming responses for the same request. So you can clearly see that there was a request that was sent to www.google.com. Now if I were to look at this, you can see that it's a GET request. So this GET request is automatically sent from my browser, and this is the URL. And you see that the status code is 200. It means that it was successfully, I successfully got back a response. Now, this was the response that I got back. It's a bunch of JavaScript and some HTML. So what the browser did was it got back this as a response, and since the browser's job is to render HTML on my page, it knew that it was HTML. It created this web page. And now you might think, there's my profile picture over here, there's the Google image over here. How to get all of that? Because all of that clearly cannot be in this response. So browsers are very good at doing this. So when you get back a response and that response contains links to other resources, so this response somewhere would contain the URL for this image, it can recursively call and send GET requests to all resources that I mentioned here. So this here would contain maybe a JavaScript file or a CSS file. So the browser recursively sends requests for all of those. So if I look at an image, there's a lot of images, I think. Let's see. Okay, let's not do that. Okay, I think if you go through all over here, there's a lot of requests here, and some of these are images. So you can see that there was a request sent for this profile picture here, there's a request sent for this image over here, so and so. So this is an example of how HTTP is being used practically in your browser. So I think, one second. Yeah, so now I think we'll get to the demo itself where we write our own HTTP API and see it work in action. Okay, so what I'll do now is I'll create a project. I'll just call it a seminar. And so what I'm doing is I'm just opening, I use VS Code, so I'm opening my VS Code in that directory. So now what I'm doing is I'm going to be using Node.js for this. So this workshop, I won't really be covering Node.js exactly, but most of it is pretty basic and you should have an idea of what's going on. But again, like I mentioned before, the key concepts are not the framework or the programming language that I'm using here, but more of how the API is constructed and what you need to look for. So what I'll do is, so if I were to create a Node.js project, and Node.js project, what I need to do is I need to initialize the project. Don't worry about all of these, it's just steps that I need to do. Okay, so now you can see that a package.json was created. A package.json essentially, it just contains information about my project. It contains a name, version number, scripts that I could execute, so and so. Don't worry about what all of these are. We'll probably get to what is required later on during the course of this demo. And now you can see that the main index.js, there's no index.js. Obviously, it's a Node.js project, so I'd require a JavaScript file to run. So I'll create that JavaScript file. And so this is going to be where I'm going to write all of my API code eventually. So how I would, so I'll just, so if I were to execute this program, all I need to do is I do node index.js, and you can see it outputs hello. So for those of you who are unfamiliar with Node.js, you would have heard of JavaScript, I'm sure. So Node.js is basically JavaScript that's running outside of the browser. So JavaScript is designed to run on a browser. So there's a browser engine that is able to interpret JavaScript. So what people did was they decoupled this engine from the browser so that we could run it on a computer, and that's Node.js for you. So now I have a node index.js. Now what I'll do is I'm going to create a HTTP API, and there's a nice little package, library you could call it, in Node.js that lets me easily write APIs, and it's called Express. So I'm just going to install Express. So if I were to install a library in Node.js, I would npm install the library name. So most of you here would be familiar with Python, obviously. So npm install is very similar to pip install. So I'm just pip installing, but in Node.js terms, npm installing Express. So like I mentioned before, my package.json contains information about this project. So now you can see that in dependencies, Express is added. So package.json keeps track of all the libraries that my project is using and all of that. So it says dependencies Express. So now if I want to use Express in my project, all I need to do is I have to import it somehow. Again, in Python, I would import Express or something. So in Node.js, I would import it this way. Okay, so don't worry about syntax again. So Express, it requires me to create an instance of the Express object. So I call it app. So I can do const app is equal to, oh yeah. So some of you won't be able to view this code, so I'll zoom in. Const app is equal to Express. So here what I'm doing is I'm just creating an Express object. This app, it need not be called app. I can just call it server or anything, but let's just call it app. Okay, so now what I want to do is, so this is going to be a server program. So it's going to be running on a server and it's going to be listening to HTTP requests that are coming and it's going to respond to HTTP messages. So what I need to do is I need to run this program in such a way that it's actually listening to messages that are coming onto a particular HTTP port. So there's a concept of a port. So what a port basically means is that in a network, if you were to identify a particular computer on a network, you have something called an IP address for that. But you have lots of programs on your computer that are listening to the same network, and if you have a HTTP message coming into your computer, you need to know exactly which program that HTTP message comes to. So you have a logical idea called as a port number. So each program would be running on a particular port number. So when the message comes to your computer, the computer knows which program I need to send this message to. So a port number is a numeric value that you can bind a process to. So I define a port number. So a port numbers vary over a lot of values. I'm just going to use a value 3000. It's a common development value that you use when in development. You would usually bind your front end to port 3000 or back end to port 8000. But you could use any number. There are some standard numbers which some applications use, but technically you could use any number. And what I want to do is I need to bind this application to that port number. So what I'm going to do is I'm going to make this listen to that particular port number. So what it's going to do is it's going to listen to a port number for HTTP messages that are coming in, and it's going to respond back. But I haven't written anything to pass any particular HTTP request. So the requests are going to come in and it's not going to respond anyway. I'm just going to get it to listen to that. And so the syntax says that I could write a function that says if the listening was successful, I could say it's listening on a particular port number. Again, don't worry about the syntax here. So okay, hope this makes sense. So what I just did was I made my app listen to particular port number port, and if it's listening successfully, I'm just saying I'm just printing onto my console that is actually running on this particular port number. So this syntax over here is a shorthand for writing a function in JavaScript. So again, if you're familiar with Python, you'd know about lambda functions where I can create shorthand functions. So the same concept exists in JavaScript where I can create something called an arrow function. Okay, so this is great. So now if I want to run this, again, previously all I need to do is run. I need to increase my terminal. I hope my terminal is visible. Okay, so if I were to run this program, all I need to do is run node index.js. So, and my server is running on port 3000. Now this doesn't make much sense to you because you have no visual feedback. I wrote some code here, and for all you know, I could have just gotten my code to just print server running on port 3000 without actually doing anything. So you'd probably want to figure out if it's actually running on port 3000. So you know what? I think I asked most of you to do this too. That is download a REST API client. Okay, so basically what a REST API client is is something that lets me test an API. So what I'm doing here is I'm creating an API, and APIs, like I mentioned before, they're meant to be used by someone else. So you could have your front end that's using your API or something, but if you're a backend engineer, you don't have a front end ready for your API already. There's some way that you need to test your API. So you have API clients that you can use to simulate API calls, and you could get the response shown in text form or whatever. So I'll just use this. So this server is running on my local computer. The server is running on my local computer. So it would be a local host. So a local host would resolve to an IP address 127.0.0.1, but it doesn't really matter anyway. So what I'm going to do is I'm just going to call something that does not exist. You see, I got a 404 response. Now, someone had to be giving that 404 response to me. I can't just get a 404 response if nobody responded. So it's clear that I requested port 3000 here. I think I'll make this big. I requested port 3000 here and I got a 404 response. If this program wasn't running, I wouldn't have got a response back. So I'll show you that again. I'll just shut down this program and I send back the same response. You see, there's no response now. So obviously this program gave me back that response. Again, I wrote no code here that actually served me a 404 response, and that's actually just a benefit of using frameworks that are useful for creating APIs. So Express, that is the framework that I used to create this API, it automatically took care. It knows that I haven't defined any particular address for /AST, and so it knows that it does not exist. It knows that I haven't written something, so it automatically threw a 404 response. So if you were writing an API from scratch, using no frameworks whatsoever and using what the language provides raw. In fact, Node.js does provide something called a HTTP module, which you could use to create it from scratch. So there you would have to take care of each and every condition on your own. You would have to see that, maybe you can imagine a bunch of if else statements looking for particular routes, particular addresses. And in the end, you take care of an else condition and say, what, this route is not found, here's your 404. But Express does that automatically under the hood for us. So now let's actually create an endpoint of our own that works. So if I want to define a GET request in my API endpoint in index.js, all I need to do is just do app.get and a particular URL. So if I want to access this, obviously I need to prefix a localhost 3000, but this program obviously knows that it's running on a particular port number, so it knows that it's going to get prefixed anyway. So if I want to say hello, what I'll do is, so the syntax here is, well, I'll explain the syntax after I write this. So what I just did is I got my application to listen to GET request at a URL /hello. So if I were to send a message to /hello, this function would be executed. So this is Express's way of writing an API endpoint. A GET request defined as /hello. It gives me a callback function with which it passes a request and response object, and I could use this response object to send a response back. I can use the request object to actually get more details about the request that was sent. Maybe some queries were written at this URL and I wanted those queries. I could get those queries back using the request object. So and so. If there are cookies, I could get those cookies with request. So all of that's happening here. So now if I were to test this, I send a GET request to hello. Obviously my server is not running here. One more thing here, you notice that every time I make a change, I need to restart this program. So I'm going to make that easier for us. So what I'm going to do is I'm going to install a package that automatically restarts my server every time I make a change. It's called nodemon. You don't need to know about this, but it's just something I'm going to use now. So you notice I've used a -d over here, which I did not use last time. So the D here stands for developer dependency. Now if I look at my package.json, you can see that nodemon got installed as my developer dependency. So what this developer dependency is that, what it means is that this package is not actually going to be used in production. So when I deploy the server, this nodemon is not going to be used. So it lets me optimize my package for production. It'll automatically delete packages that are developer packages. Now, why would I not want this in production? So how nodemon works is it monitors all the files in my server, and every time a file is updated, it's going to reload it. And I wouldn't want a process that is constantly monitoring my files on my server that is actually deployed, because it's going to eat up CPU cycles or whatever. So I don't want to use nodemon on production. So now if I wanted to run nodemon, okay, I'll explain scripts here. So scripts basically, it makes it easier to ship a package for development. I could mention my script here. So the script that I used to run this program was node-index.js. So sometimes your scripts could get a lot more complicated. You want to pass some flags to index.js. The scripts could get really complicated. And you wouldn't want to mention the exact command to execute your program. So what you could just do is in your script here, you could mention a start script that starts your project, and there you could just write the command. So it gets really convenient to have a start script like this. So it doesn't matter what the start script is, the developer who is just taking your project could just run npm start. So the same thing happened as before. npm, like I mentioned before, is similar to pip, but it's a lot more powerful than pip because it lets me manage my project in this fashion. So anyway, now I've just installed nodemon here, and so I think I have to use nodemon. So how I'd use nodemon is, so this is my start script, and usually in production when I deploy a Node.js application, the server that is the hosting provider will automatically run my start script. So I'll create another script for me to use in developer mode. I call it dev. You can call it anything. So these words, some of these words are convention, like start, test, build, all of that. If you don't know what build is, it doesn't matter. We'll probably get to that in the end of this workshop. So dev here, what I'd say is I want to run it using nodemon. So nodemon index.js. So if I were to run, so again, now last time I just did npm start. So npm space script name would work for script names that are a convention, like start and all that, but dev is not a conventional this thing. It's obviously popularly used, but it's not something npm supports inbuilt. So to run that, I'd have to use a prefix or run before that. So npm run dev. So now nodemon is running my server, and you can see that it's watching extensions JS, mjs, json. You don't have to worry about what mjs is. JSON, we'll get to JSON in this workshop. So it's looking at all of these files, and every time I create a change in one of these files, so let's say I'll show an example. So I just saved my file. You saw the server restarted automatically. Okay, this doesn't matter now. Okay, so I have a get request / hello. So if I were to send a get request here, now you can see I got back a response, hello world. But you notice that I use my h1 tag over here. Obviously, if you're using an API client, HTML is not going to be rendered. So obviously you can guess that this would work on the browser. So if I were to visit localhost 3000 / hello, I got a response, hello world. Don't worry, I'm using an extension that makes my browser dark theme. So the black and white is not caused by my server. All web pages look like that. So I did get back a response, hello world. Now you'll notice that if you compare this with my REST API client, there's actually a h1 mentioned in my REST API client, but there is no h1 in my browser. That's because the browser is smart enough to understand HTML when it sees HTML. One more thing I should have mentioned before is there's something called a source. You could control U on your Chrome, and you could view the source. So you could see the source of this page. It's hello world. So this was exactly what my API sent back. And the browser is smart enough to see that as a h1 tag, and it rendered as a h1 tag here. Okay, great. So my thing works. So now I could actually specify my route at the root also. I don't have to say app.get hello at hello. I could just do it at this thing. So now if I were to do this, you can see hello does not exist anymore. It says cannot get hello. That's because my Express server, it restarted the server here, and it knows that there exists no route for /hello. So there was no get request defined for /hello, so it sent back a response that says cannot get hello. This is basically a 404 response. I'll show you a 404 response in google.com. So if I were to google.com/pil, so it gave me a 404 error. So this 404 error is the same equivalent here, except that instead of just sending back a string, they have a fancy page with this drawing over here, and that says 404. If I were to look at my network tab over here, you know, I'll resend this request. You see that I actually got an error code 404 that says not found. So 404 is a very common client-side error that means that whatever the client requested was not found on the server. It's not a server problem because it was the client's issue for requesting something that was not available on the server. So people make this mistake. They think that a 404 error that is a server-side error because it's the server's fault for not having it, but it's actually the client's fault for requesting something that is unavailable. Anyway, so you see that this hello route has actually been shifted to the root. So if I were to go to localhost 3000, I get back hello world over here. So this is a simple API, and for a lot of you this would be your first API ever. We just got a program to listen to a GET request and send back a response to that GET request. Oh, again, you could look at the networks tab again. You can see that a GET request was sent to localhost 3000. There's a 304. It means that it cached this data and it used the cache basically. So it's a 304. But if I were to, I got a 204 because I Control-Shift-R. That's a hot reload. It deletes my cache. So I got a 200 here. So let's actually make this a little more complex. Let's make a CRUD application. Now, CRUD application stands for a create, read, update, and delete application. So we'll make a simple CRUD application where what I can do is I could create entries in a database or whatever. I'm not actually going to use a database, but we'll mimic a database using variables on the server directly. I'll mimic a database, I'll add entries to it, I'll try to read entries, and I'll try to delete entries. Maybe we'll do update entries too, but I'll probably leave that as an exercise for those of you who are in the seminar to maybe try it out after this workshop. So I need a database, so I'm not going to install a database or anything, so I'm just going to create my very own DB variable. So my DB is a list of entries that I have so far. So obviously it's an empty list in the beginning. This is not a good practice, obviously, because if my server restarts, my DB is gone. So it's not persistent. So you would use a database in real life, but I'm not going to use a database now. It's beyond the scope of this workshop. So this would suffice for now. So what I want to do is I want to write a post request. So we have obviously discussed what a post request was over here. A post request was to submit data. So what I'm going to assume is someone is going to send me data of a task to do. It could be a to-do application, but the same thing. A to-do application is basically a very simple CRUD application. So I'm just going to send in some string. I'm going to store that string, and maybe a list of all the strings that have been stored so far will be sent back to the user. So what I'm going to do is I'm going to create a post request. So if you can guess, if I want to define a post request, all I need to do is do app.post here. So if I do an app.post here, I need to create an endpoint for that. So I'll call my endpoint submit. So if I were to receive a post request to the endpoint submit, it would invoke this function here and carry out that whatever task it's intended to do. So what this post request is going to do is it's going to get the data that the user sent to me and is going to update my database. So now, as you can imagine, the data that the user is sending to me will obviously be in this request object. Some of you might feel that this workshop is getting very Node.js specific, but that's totally okay. Even if I feel like it's getting Node.js specific, all of these concepts here can be applied to most other languages, like Python, if you're using Flask in Python, or Go or whatever. So anyway, okay, so I'm going to assume that data is being sent to me, so we can design our own data. So let's just assume that there's something called data. So I need to obtain that data. So the data would be inside my request object. Now all I'm doing is I'm just going to be appending this data to my DB. So I'm just going to do db.push data. So that's basically it. All I've done is I've taken data from the endpoint that the user has sent to me, and I've pushed that data to my database. So if you're using an actual database, there would be it would be different as compared to doing this. The database that you're using would provide methods that you can use to add data to the database and so on. So now that I've done this operation, I need to actually send back a response to the client that says, you've given me data and I've successfully pushed it. So I would respond with rest.send. So rest is, I have a lot more methods inside rest. So what we used before was rest.send. So I could use rest.status to actually send in a proper status code. So I'll use the status code 201. 200, like I mentioned before, a 200 error code means successful, but a 201 specifically means that the data that you sent to me was actually updated in the database and an entry was created. So 201 corresponds to that. So you don't have to know all error codes that exist, but some of these error codes are pretty standard error codes. But if you're creating your own API that's going to be used by yourself, you could invent your own error codes with the same convention, like 200 success. You could create something called 298 that means something, doesn't really matter. So rest.status.send with the 200 response, I'll say that the data successfully submitted. Cool. Okay. So this should work. So now if I were to again use my API client over here, I'd send a post request. You see there's a bunch of requests here. I'd select post, and my API endpoint is /submit. So I call submit, and it requires a body. So I'll introduce you to JSON at this point. So what JSON essentially means is that so when you're sending data can just be string. A JSON can just be string, or a JSON so data can just be string. So but a JSON is a more complex way of organizing data. Now most of you are familiar with JavaScript. You'll know about how objects can be written in JavaScript. So I could create something called object is equal to something like this: hello, key value pairs, hello and something. So JSON is basically this notation to store data. So if you have web APIs, it's very common to see that the mode of transfer of data is JSON. So the content in your HTTP packet most likely would be JSON data, because you can bunch up data and organize in a very nice way, convert it to string, and then from that string convert it to JSON again. So now I'll create some data. I'll call it, my name. Okay, so now if I see that it says data was successfully submitted, but now, if I were to actually console log this DB, it wouldn't actually be what's expected. So if I were to console.log DB here, it'll console.log DB over here. Oh, it says, oh, never mind, okay. So now if I were to send this response again, you'll see that I got a list. My DB is a list and is actually undefined. So, but I actually did send a data here, that JSON object that says name is Sourav, but you see that it's undefined over here. That's because when you send a HTTP message, this is going to be the body, but there actually does not exist an attribute called body in the request object. So frameworks like this, obviously, to make it easier, Express has a concept called middleware. I should probably explain what a middleware is. So now, again, as you've noticed that all my endpoints over here, you're getting a HTTP packet. The HTTP packet has actually been modified by Express to this request object. So what I can do is Express provides a very neat little feature that lets me put up a bunch of functions before an actual function is called, and it's called a middleware. So it's very, sometimes it's useful to have the body inside the body attribute. So Express provides something called express.json that I can use as a middleware. So the syntax to use a middleware in Node.js would be app.use express.json. So what express.json just does is it passes this body attribute, creates a body in my request, and puts it over there so that I can use it better. So now if I were to run the same thing, I think I'll restart it. I didn't have to, but I just did. So if I send it now, you can see that my list contains name Sourav that was actually used. So express.json is a very useful middleware that puts the body that you sent and puts it into the body attribute. So what I essentially did now is I used another program that's my REST API client and sent data to my Node.js program that's currently running here. So if I were to run this again, I could send the same request again, and you can see my output. Now there's 2 of them. So my database just got updated with 2 of them. So let's make this more concrete. So what I'm doing now is just taking any arbitrary data over here. Data is equal to rect.body. It could take anything. So I could change my object, give this any arbitrary key, send, and I have 3 objects now, and they're not very structured. They're of a different format. So unstructured data like this would not be usually used in an API endpoint unless you have some good reason to do that. So every entry that would be in a database would usually have a very well structured schema. We are obviously not going to enforce that over here. We're not going to make a schema for a DB, but most databases that you use will support a way to provide a schema for your object. So the data that is in your database always conforms to a particular format. So let's just say that our API endpoint is going to look for a key called message, or let's make a to-do application out of this. So let's just call it task. So data corresponds to rect.body. What I need is task. So I will need task. So const task is equal to rect.body.task. So whatever object that I'm going to be sending from my client, I'm only going to be looking at the key task now. It doesn't matter. The other keys don't matter. All I care about is the task method. Rect.body.task. And what I'll do is I'll push task to this. So now if now if I were to do this, my list is again undefined because task was not actually defined here. So how I take care of that is, I'd have a tag for task. If not task, I would return a response. I would send a 400 response because there's a client-side error for giving me an invalid object. So return rest.status.send. I'll tell the client task required. So this way, what I did was I just did a sanity check over here to make sure that the message that the client is sending to me contains the attribute task. So now if I were to send the same thing again, I got a bad response that says task required, and nothing got printed over here. But previously undefined was printed, but now nothing got printed. So my database is not polluted right now. Now if I were to change this to task, say hello. If I were to send the same thing, my task list actually got updated and I have a task that says hello. So now you see that I have a post request that actually works. It takes data from my client, it updates my database, and it sends a response that says that my data was successfully submitted or updated, whatever. But usually your API endpoint is not going to be this simple in real life. In practical purpose, it'll be a lot more complex, and there's a very strong chance that something could go wrong. Your code could go wrong somewhere over here because maybe a check was unhandled or something. So I'll give you an example of a check that actually went wrong. So let's do console.log a.b.c. This does not exist. So I'm just trying to create an intended error on purpose over here so that my server crashes. So now if I were to send the same thing, I got back a 500 internal server error. So my server crashed, but Node.js or Express was smart enough to figure out that the program was crashing, and it actually sent back an internal server error. But now that's an issue because my server is no longer available to take requests anymore. The server's crashed and it can't process requests anymore. So you obviously need to take care of server crashes on your own. So it's a very good practice to use a try block, to put your entire logic in a try block. Okay. So if it ever reaches my catch block, it means that an error occurred somewhere. So in that case, I would return the rest.status 500.send internal server. So now I think I'll keep this over here. I'll just restart my server to remove all the logs up over there. So now my server is running a port number 3000. I have a try catch block that takes care of errors. So even if it fails over here, my server is not going to crash. I send back a response. Expected I got a 500 internal server error, but my server did not crash. So it is available to take more responses, requests. So it's a good practice to use a try catch block. So for the client, it worked exactly like how it would work before. So previously when my server crashed, I got a 500 internal server error, but my server was not actually available to take more requests. But this time the server crashed, I got a 500 internal server error, but my server is still available to take further requests. So it's a good practice to use try catch block. So how you would resolve this is, obviously when you reach a catch block, you would probably console this log. You create a log of error statements. So somebody who's maintaining the server could look at those error statements and try to find out what exactly caused the error and then fix that block and then update the server. So I'll remove my console.log here. So now my function would work as it is. Now if a standard was successfully created, I'd probably get say hello there. Now I have a post request that works perfectly. It works here. Now what I'll do is I'll need to get a get request, because it's not just enough that I submit tasks to do to my API. I also want to view all my tasks. So what I'll do is, some of you would have guessed what I need to create is a get request endpoint for the same API. So I'll do something called app.get, and I'll use something called /tasks. So when I get a get request for /tasks, I will handle it this way. I'll use the same try catch block here. It's obviously almost never going to reach my catch block, but it's a good practice again to always use the try catch block. I just need to use this again thing. So I'll just copy this from here, paste it here. So all that I'm going to be doing is this DB object here. I'm just going to send that DB object as it is straight to whoever requested it. So I'm just going to do rest dot. So what I could do here is I could rest dot send, but Express has a nice way of sending JSON data back. So I could rest dot JSON. So this way Express knows that what I'm sending is JSON formatted. So it would convert that to a string here, and on the client end, it would receive that JSON object very nicely. One thing to note is here that whenever I'm sending data over a network, it's always sent as a string. So even if it's JSON, through that intermediary network connection, it is going to be converted to a string and then reconverted to JSON on either ends. So that's a key point to note. It's not going to be sent as JSON itself to a network. That's not possible, because it has to be sent as bytes and a string. So I'm going to I'll add a status, rest.status 200.json db. It's not necessary to add the status here. When I just do rest.json db, it's also going to send back a 200 response code. But keep it uniform. Some places I've used the status, and some places I've used I've not used the status. So just keep it uniform. You can use a rest.status 200. So now this is a very simple API. All I'm going to do is send back my database, and it's almost never going to fail. So this could be redundant, but just keep it for the sake of it. And you see that my request object has not been used at all, because I don't really care about any body or anything. The person who's going to send me the request is not going to send me any body over here. This is going to request for this task. Okay, so my server is updated. So my tasks is empty. So now if I were to send a get request to /tasks, was it? I got a 200 OK, and I got an empty list here. Now I'll send a post request to to submit, and my task is to say hello. It got updated. say now I'll add another task. Complete homework. Maybe another task. Study. Okay, so I have 3 tasks over there, and now if I were to get it, oh no, I just got a 404 here because I sent a get request by accident to /submit, and that actually does not exist. So I got a 404 here, but my server wouldn't crash for this, you see, because Express very nicely handles get request to invalid URLs, as we've seen before. So it was tasks. So I'll send a get request to /tasks. You see, I've got my list of tasks. So that is very well how an API endpoint would work. I think some of you would be following me and looking at what I've just done here. Some of you may not be following, but I hope all of you have this Chrome extension or any API testing tool I've enabled here, because what I've done is I've actually created an endpoint before, an API before this workshop. I've deployed it. So all of you could actually test this API yourselves. So what I've done is I've created an API endpoint. It has 2 methods. It has a get request at /data and a post request at /submit. So usually when you create an API and you're looking at API documentation, this sort of is how your API documentation might look like. You might have documentation that says post request, it's defined as /submit. What it does is adds an item, get request /data. There's obviously an expanded version of this documentation, which I'll get to. So I think the mod will put up this chat over, the mod has put up the link on the chat here, so all of you could open this up. So yeah, so it'll take time to open because, oh, one second, just wait for it to open. Great. So this endpoint over, there's a web page over here is an empty web page. It contains nothing. That's because similarly as shown here, I actually have a database over there, but the database is empty right now. So what you could do is I've documented my API endpoint over here. I hope it's visible. If it's not visible, I'll just open this image. Yeah, so this should be visible to all of you. So what I've done here is I've created something called a submit endpoint. I've created a post request. I'm documented in this format. What it does, it adds an item to the system. This is the body that it expects. It expects a JSON object with a name attribute and a message attribute. You can mention your name and a message, and you could send a post request to /submit. And these are the possible response codes that you could get. You could get a 201 if the data was added successfully. You could get a 400 if the data that you sent contains like an invalid inputter if the name or message fields are missing, or 500 if something went wrong on the server. So these are the possible. So this is how typically an API documentation would look like. So now what I would want you guys to do is so this is open here, so you can whip out your API testing tool, whichever API client you have installed. I think I sent instructions for, installing on Firefox or Chrome, or you could have Postman, anything, it doesn't matter. So what you're going to do is copy paste this URL. So you're going to send a post request. So I'm going to click on post, and you can see as shown here, oh no, I closed that. Yeah. So as shown here, this is the object that my post request accepts. It takes a name and a message attribute. So in my body, I'll specify name, my name Sourav, and my message would be hello. And this wouldn't work now because you see in my documentation, the post request is actually at /submit. So I'd send it to /submit. Perfect. So I got back a 201 error code that says data was added successfully. Now if you go back to the same website and reload it, you'd see, great, someone's already sent data before I did. Great. So you see that data was added here, and all of you can visit. So I think I'll pause for 5 minutes and give you guys time to test out this API. You could also send a GET request to slash. Again, I've documented the GET request here. The GET request is for slash data. So my responses of this format will be a list of such objects containing name and messages, or an internal server error. So if I send a GET request to slash, what was that, slash data, I would fetch all data that's on my server right now, and there are three such messages right now. So I think I'll pause for 5 minutes and give you guys time to test this API out. So what you can do is, once you've sent your message, you could reload the page, and the message that you sent via your API client would pop up on this website. So I'll again continue. This workshop would continue, and I'd probably tell you, not probably, I am going to tell you how to actually send a request to the server that I created from a web page. I think I'll pause for 5 minutes. I'll let you guys try it out if you want to. I'll look at chat for now. Huh. Oh, please don't do anything special. Okay, there isn't that many responses, unfortunately. I think I'll continue in 2 minutes. No problem. Okay, I think I'll continue now. I don't think you guys are trying it out, but it's okay. So I think this code would be made available to you guys, so you could try it out at home too. So anyway, now what I have here, I have an endpoint for a GET request. I have an endpoint for a POST request. So anyway, now, yeah, okay. So what I'm going to do is so obviously here there's a HTML page that's doing this, and my POST request was sent, and my HTML page was able to get that data from the endpoint. So if I were to, let's inspect the network tab of this website that was just created here. So if I reload it, okay, let's just go to XHR. So XHR over here stands for XML or HTTP request. So if you're looking at a website and you're looking at the networks tab hoping to find an API endpoint that is sending back JSON or something, your best bet is to look at XHR instead of the all tab. So XHR would filter the, if it's a REST API, it'll filter that data specifically. So your image data, all of that is removed. It's not removed, it's just that it's a filter. Oh. Okay, so if I were to look at, so you can see that this page is actually sending a GET request to slash data. So this is the same slash data that I invoked over here and got back this response. So to slash data, you can see that the response actually had a list of 6 names and messages of this format. So if you were to try it out, if you guys tried it out, you could actually check for sanity checks like submit by not having a name. So if you don't have a name, the server will send back with a required name error. So you could test out things for that. So anyway, I will get on with this workshop. Okay. Yeah, so now what I want to do is I want to create an actual HTML page. So you can imagine that a HTML page is a separate application and it's going to somehow communicate with this server that I just created, because otherwise we don't actually, if I don't explain how that interfacing is happening, this API would be pretty useless to you guys. So you guys did see how this API was being tested using an API client, but we're actually going to use an actual application where we're going to write code to send a HTTP request. So what I want to do is I want to create a HTML page. So before I do that, I think I'll explain a concept called a static server. So when you have API servers, when you have a static web page, or maybe a poster website or something, it is going to be hosted on some specific server. So before HTTP was actually used popularly to create REST APIs like this. I haven't covered what REST is. I'll get back to what REST is at the end of this workshop. But here, what we have here essentially is a REST API in a sense. Don't worry about what REST is. So anyway, so it is a very common function to get your server to just serve a HTML page back to you. It won't be task specific like this. So like I showed google.com, when I requested google.com, they actually have an endpoint for /google.com/, and all it's doing is it's sending me back this web page. So it's a very common functionality that just a web page would be sent back. So I don't have to write such complicated, you could write it on your own. So what you could do is when you get a get requested /, what I could do is I could use the a file module, read a particular file, get the text in a file, send the text as a response back. But since it's a very common feature to do that in an API server, Express has that inbuilt. So there's something called express.static. So this way I can use my Express as a static server. So as you would have guessed, Express provides this as a middleware itself. So what I can do is I can say app.use and I'll do express.static and I'll provide it a URL. So I'll create something called a public directory. So now what this means is whenever I get a request, what Express is going to do is, obviously now this order of this middleware matters. So whenever I get a request, what it's going to do is the requested file is going to look inside my public directory, and I haven't created a directory obviously, so I'll create a directory called public. So what it's going to do is you requested a file, it's going to look first in my public directory. If the file exists in my public directory, so I could have something like app.get image.png. So if I get a request like this, what it's going to do is it's going to look for image.png in my public directory. If it does not exist in my public directory, then I'll pass it on to the next middleware. The next middleware is express.json. So express.json will convert that body to JSON. If there's no body, it's not going to do anything. And then it'll go to my endpoints that I created. And finally, it sees that there's an image.png, and the code here that actually sends back a response is what's going to be executed. But obviously for each and every file on your server, you're not going to create endpoints manually or get requests for each of that. So it's very useful to use express.static here. So now what I'm going to do is task, I'm going to keep that. I'm going to create something called an index.html. So index.html is going to be HTML. So if you're using VS Code, I think you can use, I think if you type in HTML5 like this, it has an abbreviation. It'll create, a template, a boilerplate for HTML like this. You could use that. I'm guessing some of you are familiar with HTML, but if you're not, that's okay. You don't have to worry about what this is, but I'll just go through it. So this here, it just specifies that we're using HTML5. Here it's this HTML usually contains something called a HTML tag. It's a markup language that basically defines how components look on your web page. So these are some things that compulsorily go into a HTML file. So I have a HTML tag and everything goes on inside my HTML tag. A head tag contains metadata about my website. Metadata is basically data about my data. So it could be used for search engine optimization if I want to provide a title for my web page, whatever. So title, I'll call it seminar. and my body is where the actual content that is going to be displayed over here goes. So if I create a h1 tag here, so no, I'll just keep it like that. I don't know, world 2. So you can see that I have a h1 tag over here, and now you might notice that I call this index.html. That's on purpose too. Could I call it something else? I could call it something else, but index is a convention again. So whenever I receive a request at the root, it is going to look for a file named index.html or index.php, whatever. We're not going to cover PHP here. Don't worry about PHP. So it's going to look for index.html. So now if I were to, what was this URL? It's running on, I'll close this image tag. It's running on port 3000. So if I were to go to port 3000, I just got a hello world again. And you see, if I look at my endpoint, I don't have a route at slash, like just slash. I don't have a route that's handling that. So what's actually happening is my express.static, my static server is handling that request. It saw that a request was sent for slash. It's looked at the public directory, found in index.html, and it served the index.html back. Modify this index.html. I got a hard hat back here. So anyway, so we found out this works. So what we're going to do here, one more thing I'd like to clarify. So you see that my server is sending this HTML file here. So again, you guys could, I think, go back to my client server architecture diagram over here. I have multiple clients all connecting to a server. It might be confusing to some of you to see that, you know, my server that has my endpoints over here is the same server that is sending back my, if this sounds confusing to you, forget it. But if you guys have thought about it, pay attention. It might be confusing that the same server is sending back my index.html. So is this index.html my server or is it my client? So that could be a valid question that you guys could ask. The answer is it is my client, because for all practical purposes, when I have a static directory here, my Express does not care about what's in my static directory. For all practical purposes, these are just text files, or it could be code files too. And when it gets a request, all it's going to do is it's going to take that file and dump it to you. This index.html is actually executed on your computer. It's not going to be executed on the server. So if I have some JavaScript there, it's going to send you a JavaScript file. It's going to be executing it on your client. So it is a client, and it is not the server. Actually, the server is just sending you the client program to run on your client. So we are still following the client server architecture over here. To some of you, that could have been a really stupid question, but it is a valid question if you guys are new to this sort of stuff. So index.html has nothing to do with your server. It's just a program or a file that the server is sending to run on the client. Anyway, so I have my static server here. So now what I want is, I want to create a JavaScript file. So what I'm going to do is my JavaScript file. So I have my tasks here. So some of you will know that HTML really is not a programming language. It's a markup language. So if I want to write code to do or perform something, I'd have to use JavaScript. So I create a folder called, create a folder, call it JS, add in a JavaScript file here. So I have my index.js here, and what I'll do is I will add in my script tag here. To some of you who are confused about the syntax, don't worry. All I'm doing is my HTML is there and I have a JavaScript file here. I've just connected my HTML file to my JavaScript file so that the code I write in my JavaScript file can be executed on the browser. So now what I'm going to do is I need to get this data. You see, I have, I'll go back here. I have two index.js's. That could be confusing. So you know what, I'll rename this to main.js. So my index.js is actually my server program. This main.js is not going to be running on my server. It's going to be sent to the client and it's going to be executing on the client's computer. It's not going to be executed at server side at all. But this index.js is the server. It's going to be executed on the server. Now what I'm going to do is I'll create a function that is getting my data, function get data. So what my get data function is going to do is it's going to send a request. So far we've observed requests is being sent from my API client here. I have my get request here, and what was it called? We called it tasks. Oh no. So we're going to simulate the same thing on the client. Sorry, okay. Yeah, so now if I want to mimic a HTTP call from my browser client-side JavaScript, JavaScript has an inbuilt function called fetch. So fetch lets me send a HTTP request to a particular URL, get back the data and do something with that data. So you could look up fetch documentation, you can Google it up. Me myself, I keep forgetting the syntax for fetch, and I'll probably be Googling the syntax for a fetch request soon, but anyway, so I'm going to call fetch, and the URL is slash tasks. Don't worry about the syntax again. So JavaScript has this concept called asynchronous programming, and it deals with asynchronous programming by means of something called a promise. You don't have to know what a promise is. The syntax, don't worry too much about the syntax. Just know that to resolve a promise, I have to use something called the dot then. So what does dot then means is, so a network call is going to take time. So it's happening on the network. So I don't know when it's going to happen. So a dot then will be executed when this is resolved. So a dot then is going to get back a response. Now, again, like I mentioned before, this response is actually a string, even though I JSONified it. So I'd actually have to convert it to JSON. So to do that, I'll press.json. This shorthand over here is shorthand for a function. So all that it means is when fetch happens, this function will be executed. And what this function is doing is converting this rest to JSON and returning it. So when that JSON conversion happens, I'm going to have res. All that I'll do now is I'll just console.log res. So a promise could go wrong, meaning an asynchronous task could go wrong. So I have a catch field for that also. So I would console.log error here. So if some of you have trouble understanding the syntax, if you don't know JavaScript, I can understand that it's going to be hard to catch up, but don't worry about this. All that I'm doing here is I'm sending a HTTP request to the URL /task, getting the response, converting it to JSON, and then after it's converted to JSON, I'm just printing out the response. And if something went wrong over here, this catch field would reach. So this catch would automatically go, it would go, if my server sent back a 400 response, it would go to my catch. If the server sent a 500 response, it would go to my catch. Anyway, so what I'll do is I will just call this. So some of you might have noticed that I included my script tag at the bottom here, but some of you might be familiar with JavaScript or use HTML. You guys could have seen that script tag could also be included in head tag. I'll get to the difference between inserting it into the head tag and the body tag a little later. So I'm going to run this. Now if I look at my console, oh, okay. Oh, so it does not find a index.js because I renamed it to main.js. So I'll just rename my file here. So it found, and I console.log. You see that my get data, I'll probably add more console logs, console.log, getting data. So it's getting data and it finally got that data and it printed here. You know what? You might also want to know what this initial response looked like. So yeah, so this response object, you saw that I actually got a 200 error code, and the body, that is this object here, is actually inside this body tag, and these were some of the headers, but I don't think we can see that. That's fine. This is the URL that I requested, all of that. So the response does contain other information too. again, not relevant. So now what we're going to do is we will revert that back. Oh, great. So now my data is this way. So let's actually add some data via my this thing and see if I actually get that data back. It was /submit, and my API requested, what I needed was a task. So it was created. Now if I were to reload this page, you see that my HTML page actually got back that say hello thing that was actually saved on my server here. Now all that's left is my HTML via JavaScript is actually getting data, and somehow I need to display that data on my HTML page. Now if you look at the PL workshop here, what I'm doing is I am displaying data here. Did my server shut down again? Oh, there's a lot of people here. Nice. Okay, so my web page is actually displaying data here, and someone need to do that. Now to do that, again, I need JavaScript. So what I'll do is I'll create another function, maybe function render data. So what render data is going to do is it's actually going to get that data, going to iterate through it and display it on the web page. So what render data, what I need to do is I have a .10 here. So what I need to do is I need to send it to render data. No, it's res. So now my render data has a list of tasks that I need to do, and I need to create a list. So to do that, what I'll do is I'll create a UL tag here, and I'll give it an ID. So if you don't know what an ID is, in HTML you have all of these tags. You want to identify these tags because maybe you want to use it in JavaScript or you want to reference it in this thing. So this is how HTML lets us identify elements. It lets us give us an ID to it, which you can call an element by ID, or it lets us give a class name. So you could use an ID or a class name here, it doesn't really matter, but the convention is that an ID is unique. So if you have an ID for a particular object, that is the only object in the entire web page that has that same ID. A class name could be varied. So if you have a web page that has some buttons, you can have a class name buttons for several buttons. But if you have a very specific button that says add button, that would be an ID. But if you want to apply like a style to every button, you give a class name to it. But here I'll just use an ID. I could use a class name too, it doesn't really matter. So so my ID would be my list. So what I'm going to do is I'm going to try to access this list. So I'll do const list container is equal to document.get element by ID. I forgot what I called it. It's called my list, so I'll call it my list. So if you're familiar with JavaScript, you could use query select here, but it doesn't matter. So for those of you who don't know what's happening here, all I'm doing is I'm using my JavaScript to get access to this element that's called my list. So now my list container actually is a reference to this UL tag, and I could manipulate that tag. So JavaScript very nicely, browsers, they tie up JavaScript very nicely with HTML. That lets me actually modify, update, delete, modify HTML that's being rendered over here. It does this by this very nice idea called DOM, that's called a document object model. So this entire document, it creates a tree out of it, and it's called the DOM tree, and JavaScript lets me modify that DOM tree. So now what I'm doing is I have data, I want to iterate through data, and for each data item I want to create a list tag and add it. So this isn't a very nice way to do it, but it works, so just bear with me for this. So content, I'll create content, it'll be an empty string at the beginning. I'm going to iterate through tasks for const task of data. So if you use Python, if you want to iterate through a list, you do for I in list. So in JavaScript, the way I iterate through a list is for off. I'd use the keyword off. So for const task of data, what I want to do is I want to create an li tag for each of this data. So I do content plus equal to, I create an li tag, li, I close that li, and in my li, I would do task. This works. Now all I'm going to do is list container dot inner html is equal to content. Some of you have done JavaScript, this might seem like an icky way to do it, but it works. How else you could do it is you could actually use DOM manipulation methods. There are functions that let you create a HTML like const list element is equal to document dot create element. I could create an element called li, and then I could add my task as a child of li, and then keep appending each of these li tags to my list container. I could do that too, but this works, so let's just do this. It's very unlikely that you would actually be writing code like this when you're reading your endpoint, but this is very basic. It's not likely that you would actually be writing this code when you're creating an actual website. But if it's a very basic website and your speed or whatever is not necessary, you could do this. So now, what's happening here is I have an empty list over there. So my render data is actually not rendering any data. So I think I'll send, might have an empty list. I think restarted, yeah, it restarted. So I'll send that. After I restart it, I actually got a list that says hello. Let me add in more data. That's this was amazing. No, this is cool. So I reload that page. I have two elements in my list. I have say hello and this is cool, and both were added in my database here. So I'm actually now able to render data that was on my server. I'm able to get data using my get API endpoint. My JavaScript and my HTML file is able to fetch that data, render it. So what's happening right here is it's called client-side rendering. So what client-side rendering means is that your client is sending a request on its own for data specifically, getting that data using JavaScript and DOM manipulation and rendering that data manually into the browser. So there's also something called server-side rendering, which I think I'm not going to demo server-side rendering, but I'll explain what server-side rendering is. So that's two ways. So initially, before, people used to utilize server-side rendering because client computers were slow. That's long ago, and they weren't capable of processing too much on the client. But now technology is caught up. Your computers are capable of a lot of performance on the client. So client-side rendering is catching up, where your client is responsible for actually rendering all of this data here, sending requests and all of that stuff. So I think people are moving towards client-side rendering, but over client-side rendering libraries, server-side rendering libraries are added. Let's not worry about all of that. So anyway, we are able to do that. So now again, you might notice I'm sending a GET request. Now what if I want to send data from this web page to my server? Now obviously I'm going to be utilizing the post request for that, but how to actually do it? So I would require an input tag. I'd leave that URL tag somewhere, and I think above it I'll remove the hello world. So create an input tag. Input id is equal to, I call it my input. It looks terrible, but it works. Don't worry about it. And I'm going to create a button. Button id is equal to my button. So I should have, it's a tiny button, so add task. So I have an input tag here. I hope this is visible. I have a dark mode on. I think I'll disable dark mode for this because that, you know what, yeah, okay. So yeah, you should see an input tag here and a button that says add task. So now what I'm going to do is when I click this and I add task, a task should be added. So you see we're creating a to-do application. So now what I do is I bind a function to this. I create something called an onClick. So this onClick. So what an on-click does is when I click that button, it executes a JavaScript function that I've already defined that does something. So yeah, on click, what I'm going to call is, I don't have a function yet, but I'll create a function called add task. On click is equal to add task, and I would pass nothing, it doesn't matter. I'll just call add task. People don't really use on clicks directly like this. It's fine. Never mind. Okay, so what I'll do is, I've called a function called add task. I need to have that add task function, so I'll create a function for add task. So let's see that it's working. So I'll say I was clicked. Oh no, yeah, I was clicked. So when I click on it, I should get a log that says I was clicked. Yay, it works. Sorry, okay, yeah, so I was clicked. Now what I need to do is I need to get data over here. So I have input. So what I'll do is const input tag, const task is equal to document get element by id. It's called my input dot value. Now if I just console.log task, it's a good idea to keep testing that it's working at every point, so that you write a huge function and you realize that it's not working. It takes time to debug, so each step you debug. I think it's a good practice. So anyway, now what I need to do is I have my task here. I need to send a post request to my server, and as you've noticed, my submit, it requires an object of this format. So I need to create an object of this format. So before that, let's actually test if the user has added a task or not. So if not task, I will return alert cannot submit empty task. So if I don't have anything, I get an alert. If I have something, I'm not going to get an alert. So that works. Now what I'm going to do is I'm going to send a fetch. No, let's actually create the data. Data would be, I have a task key, and my value would be this task string. In JavaScript, I could do this, but there's a shorthand to just do this. I could just do task. JavaScript very nicely, when I have just a variable here, it automatically assumes that it's the key name, and the value name will replace here. So this is the equivalent of doing task colon task. So if your key name happens to be the same variable name, you could just use this as a shorthand. So I have my data here, and I need to send a fetch post request. I already forgot how to send a fetch post request. I'm going to look that up. So fetch post request, I've obviously already googled it. So you can see that this is the syntax for sending a fetch post request. I would call a fetch function, and I would pass an object here that this object is basically header data, and I'd specify a method post, and I also need to specify that the content type is application/JSON. So what I'll do is I will fetch slash with the URL was submit. Okay, and I'm going to create an object here that says the method with post, and I'm just going to copy this. I have headers here. Okay, and it also requires a body, because a post request, I'm going to send a body to it, because it has to post something. So the body would be JSON.stringified. Okay, so what I'm going to do is my body attribute would be, so again, like I mentioned before, whenever I'm sending data over a network, it has to be a string format. So this is a JavaScript object. I need to convert that to a string. So I would have to string it. So JavaScript has an inbuilt function called JSON.stringify. It stringifies, as you know, it converts this JSON to a string. So I would send data. Now again, like I mentioned before and I showed before, a fetch function is a promise. So the syntax is like this. So I'd call it dot then res I don't really care about what the response is because there's only one way it could have gone successful. The only way it could have gone successfully is if the object was inserted. So I'm just going to console.log item added successfully dot catch. Okay, so hopefully I think this would send a fetch request to my this time. Let's see if it works. So there's no object. I say hello. I add task. I got a response that says item added successfully, but it doesn't automatically reload here. We'll have to write code for that. So if I reload here, it actually got updated. So if I add another task, let's just say ASD, and actually got updated. So I could open this up in any tab and I still have all of that because the data is stored on my server. So that works. So the auto reload thing, it's not really an API thing, but let's just go ahead and implement it. So how would the auto reload thing work? So all that I need to do is every time, so there's two ways that you could do is every time I add task, I could manually just add that to my, I could just call render data with maybe create a global variable here that contains all tasks so far and just call render data every time. Or all that I need to do is I just need to call get data here. So get data would get the data and then render it. So now if I say hello, it automatically updated here. Now I probably want to remove this from my task because I could add it a lot of times. What I do is I'd also, one sec. I would set the value of that to like an empty string. So this way, if I say hello, add task, it gets removed from here and is added here. This works. Now if I I have a create and a read application. So I think I'll leave it as an exercise for you guys if you want to try out to actually add maybe an update task feature. So think about what extra things you would have to add to this application to create an update task. Now if I want to, I'll probably have a button that is rendered next to it that does an edit button or a delete button. So when I click on that edit button, I need to, another input box should pop up and it lets me input a new string, and I would send a put request to that particular element that says updated. So you might have to think here, because now you see that my database is pretty basic. All that I have is a list of strings. It's a list of strings. So if I wanted to identify a particular entity, I would have to string compare. So if I were to send this and find a string by say hello, I would be string comparing my database for everything. So if there are multiple say hellos, all of those would be updated. So you'd probably have to introduce a concept called an ID to identify each element. So your database, this simple database would get a little more complicated. Each entry in your database list would be a list of objects containing an ID attribute and a task attribute. And the ID attribute would be what you would be using. The ID attribute would be assumed to be unique. So this issue you wouldn't really face having to create like an index like that when you're actually working on a real project, because you'd obviously use a proper database software that has something called an ID inbuilt. So it would create an ID for your database entries automatically, which you could use to query. So I think I'll end the demo here. So what else you could do is, if you notice that it looks a little more fancy than this. So all I did was I went to Bootswatch. So most of you might be familiar with Bootstrap. So Bootstrap, it could get a little boring. So Bootswatch, okay, I'll tell you what Bootstrap is. So CSS is something that you use to style your web page, and it's annoying to write CSS each and every time you want to create a ready-made component, a standard component. So you have CSS libraries available And CSS libraries, what they do is they contain pre-built components. And pre-built components look like this. If you want a navbar, a button or something. And what it does is it provides, all you need to do is you need to import this CSS library, look at the code here, just copy this button. So you see that the class name, it references a particular class name. So the CSS library is already defined styles for these class names. That's how these CSS libraries work. So all I did here was I used some random theme from Bootswatch here, and I used those class names here to create my navbar and a little more fancy list over here. So you could try that out after that. I think this should be the end of my. Could you show the Express code again? Yeah, sure. I hope I'm not too late. The code files will be sent to you, so don't worry about it. You would be receiving these code files. I think this would be the end of my seminar, the demo. Hopefully what all we've learned so far is, what an API is, how to write your own API, how to, interface it. It's a very common issue that people face. They create their server, they create their front end, and people say, I need to sit and connect my front end and this thing. So it's that part that a lot of people are clueless about, how to actually interface your client with your server, how to send a HTTP request, how to respond back with a HTTP response, and how to render it. So what I showed was client-side rendering. Now, I'll just mention server-side rendering also before I wrap up. So I showed what client-side rendering was, where the client was actually getting data and then rendering it manually. Now you might think that, this data that is on my database, it is at the point of requesting it, it is static. It's not going to be changing a lot once you've reloaded a page. You'll have to manually reload, especially for this web page. I have to manually reload it whenever someone sends something. It doesn't auto reload something. So at the point of requesting, it is pretty static. So this data could actually be added into the HTML by the server, and the server could send that HTML back to me with the added data. So there, what's happening is the server has access to the data, server has access to the HTML page, it adds in that data as a string to the HTML page, and then sends that updated HTML page back to you as response. So there, the client didn't actually do any work. The server actually rendered the HTML page on its side, created the HTML page for you, and sent it back to you. And that's server-side rendering. So for Node.js, I think there's something called Handlebar, I think. That's a very nice server-side rendering engine that lets you add server-side rendering. Flask internally uses, I think, some Jinja framework to add server-side rendering. So most of these languages have some frameworks for backend will have some method to provide server-side rendering. But you know what? You don't have to always use server-side rendering. You could just do client-side rendering. So you have many frameworks on the front-end side that help with client-side rendering. So React, Angular, Vue.js, they're all popular front-end frameworks. So all of these are built with client-side rendering in focus. So you could build your front-end with React.js or any of these frameworks. So this seminar is obviously not going to detail those frameworks, but those frameworks that make front-end development a lot more easy. It gives a more logical aspect to front-end development, and you could build your front-end there, and the rest of it would be same. You have a server, you would get your React application to send a fetch request, or there's other libraries also that simulate the same fetch functionality. You would send it, you would send get data, and then you would render data on the front end. I think I'll wrap up, but before that, most of you while registering had a very common question that, web development, there's a lot of frameworks available. There's a lot available. How do you go about with learning what's right? How do you decide what's right? And how do you stick with something, or maybe how do you keep up with all of those frameworks? So I think I'll answer that question. You can't keep up with everything that's happening there. So what I'd recommend is you pick something that's really popular. So there's many stacks popular right now. I think Mern is one of them, Mean is one of them. You could have Django and React, any of them. So pick a server-side framework, pick a client-side framework that you think you want to learn. Invest time into learning that front end and that back end framework. Get good at it. And once you get reasonably good at that front-end and back-end framework, you'd be in a position to pick up other frameworks and try other things out too. So that'd be my recommendation. Just find one thing that's really popular, has a lot of support online, learn that really well. And when you learn that really well, you will know what that lacks and how you'd cover up its shortcomings by using maybe another framework or something, and the benefit of different frameworks and what you'd want to use for a particular use case. Sorry, before I end again, I'll probably want to plug in a very popular CSS framework right now. It's called tailwindcss.com. So I'd recommend that anybody who's spent time writing CSS, please check out Tailwind CSS. It's a whole new perspective to designing with CSS. So if you use Tailwind, you end up not having to write a single line of CSS. So the author of Tailwind CSS has actually written a very nice blog detailing why conventional CSS is actually not a very good idea and why all of us don't do this. I recommend that you guys give this a read and try using tailwind.css. Trust me, in the beginning it might look ugly, but you will get used to it and you'll wonder why you haven't used it before. So I think with this, I thank PASS Innovation Lab for giving me this opportunity, and